So good morning all. In object-oriented programming using Java course, we are now going to say about abstraction. In previous video we saw about polymorphism and types of polymorphism and how to achieve it. So let's move on to the topic abstraction now. So abstraction in Java is the process in which we only show essential details of functionality to the user. The non-essential implementation details are not displayed to the user. For example, if we consider a car, we doesn't need the technical details of the car, like where the car is manufactured, where the doors are manufactured, so how the engine operates. So these are the internal details that are particular to the car. So we doesn't need the technical details. We only need the driving skill to drive the car. To drive the car, the driving skill is enough, but the technical details like where the car is made, the make, the year, where the different parts are made, in which company those parts are made, that is none of our business. So when we want to hide some details and want to show only the essential features, that process is called abstraction. Okay, in Java, abstraction is achieved by interfaces and abstract classes. So we can achieve abstraction using interface also and using abstract class also. Data abstraction may also be defined as the process of identifying only the needed characteristics of an object, ignoring the irrelevant details. The properties and behaviors of an object differentiate it from other objects with the regular type and also help in classifying or grouping the object. So abstraction is nothing but showing only the necessary details to the user and hiding the unnecessary details or implementation. So this is abstraction in general. Okay. So Java abstract classes and Java abstract methods. So let's see what is class and what is abstract method in Java. So an abstract method is a class that is declared with the abstract keyword. Okay, so the abstract keyword is mandatory. So if we use the abstract keyword alone, the class will be declared as abstract class. An abstract method is a method that is declared without implementation, that is, we don't have the body of the method. So that type of method is called abstract method. So an abstract class may or may not have all abstract method. Some of them can be concrete methods, some of them can also be normal methods. An abstract class can have also the abstract method and also the normal method. Okay, so the abstract class can have the abstract method alone, or it can have normal methods. A method defined abstract must be redefined in the subclass, thus making overriding compulsory or making the subclass itself abstract. So whenever we use abstract class, the overriding is necessary to provide body to the methods. Okay, so any class that contains one or more abstract methods must be declared with an abstract keyword. We can be number of object of an abstract class, that is, an abstract class can directly initiated with the new operator. So abstract class can have parameterized constructor and the default constructor is always present in the abstract class. So these are all the basic details about the abstract class and abstract methods in Java. So when to use abstract classes and abstract methods. So I told you that abstraction is hiding the unnecessary details and showing only the necessary details or implementation to the user. So that is abstraction. So when to use these abstract classes and abstract methods, let's see. So there are situations in which we will want to define a superclass that declares the structure of a given abstraction without providing a complete implementation of every method. In superclass, we are just giving the structure to that class, we are not giving the detailed implementation in that class. So this is the situation. Sometimes we will want to create a superclass that only defines a generalization form that will be shared by all of its subclasses, leaving it to each subclass to fill in the fields. In superclass, we'll just implement we'll just only give the structure to the class, and the further implementation will be carried out in the subclasses only. So consider a classic shape example, perhaps used in a computer aided design system or game simulation. So here the basic type is shape. So and each shape has a color, size and so on. So the basic class or base class is shape. So in that base class, we are initializing that a shape has a color, size and so on, the characteristics. Okay, so the base class is shape. From this specific types of shapes are derived, that is inherited. For example, circle, square, triangle. So these are the particular shapes inherited from the base class called shape, each of which may have different additional characteristics and behavior. For example, the circle class, circle subclass has some behaviors which is specific to the circle, and also the square class has some characteristics which is specific to the square alone. Like this, the base class shape will provide the information such as the shape has some color, size and so on. That detailed implementation will be carried out in the subclass, which is circle, square, triangle and so on. For example, certain shapes can be flipped also. So these are the different behaviors we have to implement in the subclasses. So some behaviors may be different, such as when you want to calculate the area of a shape. So these things will be carried out in the subclasses only. So next one, let's discuss with a practical example. Let's take the ATM machine. In an ATM machine, we can perform functions like withdraw cash, deposit cash, cash balance, print bills and so on. For example, if we are going to withdraw cash, what as a user we do, we enter a card, put a pin and get the amount, or will collect the amount. So the background process, like the ATM machine contacting the server, bank server, and it will check a balance, then only it will provide the amount. So these are the background process that are not necessary for the user. So even though it performs a lot of action, it doesn't show us the process. It has hidden its process by showing only the main things like input and giving the output out. So this is the one of the best real world example of the abstraction concept. So the best example is ATM machine. Okay, so the next example is the most commonly used is mobile phone. On a mobile phone, we can perform so many actions like making a call, sending messages, taking pictures, downloading software, etc. So we perform a lot of things, but here also we don't know the inside process of these things, in which website it is, from which website it is downloading the software, which is the source for the software. We don't know that type of technical details. Okay, so which is hidden from the user, which means the implementation parts are hidden. So this is also one of the best example of abstraction. So thank you.